In part 1 of this video series, we talked about indirect injection, one of the two basic types of fuel injection. Now let's talk about direct injection. Direct means the fuel is injected directly into the combustion chamber. The challenge with this type of injection is the pressure inside the combustion chamber is much higher than that of the pressure in the intake manifold of an indirect injection system. For the fuel to be pushed out of the injector and atomized, it must overcome the high pressure in the cylinder. Indirect systems have a single fuel pump in the tank that provides adequate pressure for the system to operate, usually 40 to 65 psi. Direct systems utilize a similar pump to supply fuel to the rail, but require an extra mechanically driven high pressure pump that allows them to overcome cylinder pressure. These systems usually operate at 2000 psi or higher. Direct injection systems can be identified easily by the location of the injectors going directly into the cylinder head, as well as the additional lines and mechanical pump, usually visible above the valve cover. The primary advantage of direct injection is that there is less time for the air-fuel mixture to heat up, since the fuel isn't injected into the cylinder until immediately before combustion. This reduces the chance of detonation, or the fuel igniting from the heat and pressure in the cylinder. This allows a direct injection engine to have higher compression, which itself tends to higher performance. Another advantage is reduced emissions and fuel consumption. The overall performance and efficiency of direct injection can't be matched. However, there are still some disadvantages to it when compared with indirect injection. One of the most well-publicized is carbon buildup on the back of the intake valves. Fuel is a great cleaner, and the fuel spray from a port-injected engine keeps the back of the valves clean. Without it, excessive carbon buildup occurs, leading to interrupted airflow into the engine, reduced performance, and an expensive repair. While not an issue for typical everyday driving, indirect injection is limited at high engine RPM because there simply isn't enough time for the injector to release the fuel and for it to properly atomize. Since port-injected engines spray fuel before or as the intake valve is opening and complete vaporization occurs and the air is pulled into the cylinder, there's no RPM limit with indirect injection. Low-speed pre-ignition, or LSPI, is a common term you may have heard, and it's a problem that exposes another chink in the armor of direct injection. The piston and combustion chamber design of a direct injected engine is very specific to create the proper air turbulence to completely vaporize the fuel for combustion. At low RPM, the piston is not able to create the proper turbulence, leaving unvaporized fuel pockets that combine with contaminants from oil vapor and carbon buildup, leading to pre-ignition. While this problem specifically occurs on direct injected engines, it can worsen with some engine oils, depending on the additives they contain. This is why new oils are advertised to prevent LSPI. As engine technology advanced, diesel engines saw changes in piston and combustion chamber design that allowed them to make the switch to direct injection and realize the same performance benefits. So your two basic types of fuel injection are indirect and direct. There are advantages and disadvantages to both. What's next? The simplest solution in the book is dual injection. Now manufacturers are building cars with both. Computer control utilizes both systems to eliminate the weaknesses and exploit the strong points of each type of system. Thanks for watching.